This video demonstrates a few relational operators. We're going to write a program in which there's a hidden number and the user can try to guess what the number is. So let's start by having a hidden value. We'll call it hidden num. And I'm going to make this number 46. And then ask the user to guess a number between 0 and 100. And they can make a guess. And then we will get their guess. So we need to have another variable here. It'll be their guess, and we'll just initialize it to -1, because we know since their guess is supposed to be between 0 and 100, their guess should not be -1. So I'll use -1. So now we get their guess. That's a good start. Let's check to see how we're doing. So we want to compile, and I have an error. It is line 13. It's forgetting a semicolon before CN, which is on the line before. I make that mistake pretty often, but it's an easy fix. All right, let's run the program. Guess a number between 0 and 100. I don't know, 50. Okay, program looks good so far. So now we need to give the user some kind of a feedback. So let's say if their guess is the hidden number, then what do we want to do? In this case, we want to say, you guessed right. That looks good. And maybe we'll actually add in an end line. There you go. So if I were to, let's recompile and run the program, and if I were to guess the wrong number, it said I was right, but the number should have been 46, not 50. Let's try again. What if I put in 46? You guessed right. Okay, what if I guessed 100? Oops, I need to run the program. And what if I guessed 100? Oh, I'm doing this completely wrong. Let's run the program correctly. And then, what if I guess 100? Guess 100 is you guess right. So there's something definitely wrong. This is always evaluating to true. Why is that? Well, we are using the assignment operator, not the relational operator for equivalency, which requires double equal signs. And when you have just a single equal sign like this one, what ends up happening is the value in hidden number gets assigned to guess. Then the if statement just looks at what is guess. And if guess is not 0, then it gets evaluated to true. And the cout statement will be printed. So that's what happens. If guess were to be 0 after this statement was evaluated, then this would not print. So we can demonstrate that by changing hidden guess to 0. So now what will happen in this line of code is the hidden num, which is 0, will be assigned to guess. So guess will become 0, and then we'll have if 0, which means if false, then it will just skip that. Let's take a look. So I could guess 50, and it wasn't correct. What if I guessed the correct number? The correct number was 0 now. The hidden number is 0. So what if I guess 0? Still incorrect. This statement right now will always evaluate to incorrect. All right, so that's why we need two equal signs. I'm going to change my hidden number back to 46. And now if we use two equal signs, let's see what happens. If we use 46, you are right. If I try 50, it doesn't tell me whether I'm right or wrong. Okay, that's good. Now what if the guess were greater than the hidden num? So we could tell the user right here that your guess was too high. Add an end line. What if the guess were less than hidden num? Well, then we could say your guess is too low. That works out pretty well. Let's test to see if we've got that behavior correct. We'll recompile, run the executable. Let's guess 50. It says your guess was too high. All right, that's good. What if we guessed 40? Your guess is too low. And what if I guess 46? You guess right. All right, that's working out pretty well. Now I want to throw out one more message, which is if they didn't guess it right. So if their guess was not right, Then I want to encourage them to try again. So if one of their guesses was wrong, either it was too high or too low, then it means it wasn't right. Then we just want to encourage them to please try again. Otherwise, we might discourage our users. They have quite a feat ahead of them. All right, oh, we have an error message. Line 27, which is this line here, error hidden was not declared in the scope. Hidden is not the name of the variable. Hidden num is the name of the variable. So I'm going to paste in the correct variable name and then run the program. Guess a number between 0 and 100. Let's say 50. Your guess was too high, but we didn't get the encouraging message. What about if my guess is too low? I didn't get an encouraging message. That's odd. What's going on? Well, something's wrong with this condition. Something's evaluating incorrectly. And here's what's going on. The order of the equal sign and the exclamation mark is incorrect. They need to be in the other order, which is not equals. And that's the way it would be said, is not equals. The other way I had it was equals not. And what this actually does is it becomes an assignment operation. The not, the exclamation mark, gets associated with the variable here. And what it does is evaluates the variable depending on what the value of the variable is. So for example, if hidden number is 46 and we not 46, then it becomes 0. And then we assign 0 to guess. And if 0, then we do not run the cout statement. And so we'll never actually run the cout statement. If hidden num were to be 0, then the not symbol here, the not 0, would be anything else besides 0. It should evaluate to 1. Then we'll assign 1 to guess, and if 1, which is true, 1 is true, anything that isn't 0 is true, and 0 is false. So if true, then we'd run this. So watch, if I change hidden num to 0, then we will get that message, even if we're right. Your guess was too high, 46. Ooh, my hidden number is actually 0. So your guess right, and please try again. And that's because the way this expression is evaluated. Okay, even the white space I added there was for visual purposes, but the program would work the same if I had those operators next to each other. So I'll recompile just to demonstrate that's the way it works. You guess right. If I guess 4, you guess too high. Please try again. Okay, so we need to make this not equals. Now this is one operator, not equals. I'm going to put the guess number back to 46. Save. Let's recompile. Run the program. Say 50. You guessed too high, try again. 40. You guessed too low, try again. What about 46? You guessed right. There we go. Thank you.